Welcome everyone to our webinar on RoHS compliance, understanding the testing and the certification process. This is a joint webinar organized by Cotecna CPS, Wimpey Laboratories and VOC team, which are all part of Cotecna Inspections. I am Avni Kumar Patkur, heading India Sales and Marketing with Cotecna CPS. Agenda for today's webinar is to discuss and understand the intricacies of the RoHS testing and certifications. Let me introduce the eminent speaker for the day. From Cotecna CPS, we have Dr. Shobhit Srivastava, Associate General Manager Analyticals. From Wimpey Laboratories, we have Dr. Neha Goel, R&D Chemist, and Mr. Aftab, who is a manager with Wimpey Laboratories. We have Mr. Noor Al Hassan Mirza, who is heading Middle East VOC Business. Now, before we get into the details of RoHS compliance, I would like to brief you about our organization. Cotecna is a Swiss-based company founded in 1974, and as on date, it has expanded its footprints across the globe in more than 50 countries with presence of 180 offices with labs and more than 6,000 employees. We are glad to share with you all that this year Cotecna is celebrating its 50 years of service delivery in TIC industry. Cotecna CPS has state-of-the-art laboratories in India, Bangladesh, and Dubai. In India, we have complete capabilities for soft line, hard lines, leather and footwear, electrical and electronic product testing, toys, and analytical testings. In Dubai, we have capabilities to deliver on soft lines, hard lines, leather footwear, toys testing, and analytical testings. In Bangladesh, we can cater to the requirement for soft lines, leather and footwear, and analytical testings. We have a very capable team of inspectors in our inspections and audit team with capabilities for inspections of all product categories. And we can offer inspections not only in India, but also in Sri Lanka, China, Bangladesh, Vietnam, Malaysia, Brazil, and Pakistan as well. Moving on, there shall be a Q&A session at the end of the webinar. So you may please note down any queries or questions that you have in your mind and ask our expert panel through the chat box. Over to you, Dr. Shobhit.
Thanks, Mr. Avni, and good afternoon, everyone. Myself, Dr. Shobhit Srivastava, and I will discuss about the regulatory requirements on the RoHS, which is also known as RoHS, that is Restriction of Hazardous Substances. As all of you are aware that we are living in the age of electronics. We are surrounded everywhere around with electronic equipments and electrical equipments, and this after the life when the life of these electronic or electrical equipment goes off, then it generates the waste. Next slide, please. This is the background. Since there is a rise in the use of EE products like mobile phones, computers, and kitchen appliances, which resulted a vast increase in the EE waste, and these waste contains various hazardous substances, and during the use, treatment, disposal, everywhere it can release the various hazardous chemicals. So EU has first initiated one directive called the RoHS directive just to restrict the use of hazardous substances in EE products. And this also promotes the collection and recycling of these EE products. Next slide, please. Okay, this is the objective. What was the this is the objective? That main thing is that the various components present in the electrical and electronic equipments can have the certain hazardous substances, and the objective is to replace these hazardous substances from the safer alternative. And these restricted substances includes like heavy metals, flame retardants, and plasticizers. Plasticizers are mainly used to make the polymer like PVC or PP. They are all polymers are very rigid in nature, so make them soft. They are used. This RoHS directive promotes the recyclability of EE equipments. Next slide, please. Okay, these are the directives, main directives. This was introduced in 2003, The directive name is 2002/95/EC, and this is the original directive, and this restricts 6 substances of hazardous components, hazardous material in the various electronic and EEE products. There is a big list of categories which are exempted from the compliance of this RoHS directive initially, and this is in parallel to the WEEE directive, which regulates the recycling of EEE products. Then in 2011, one more directive was introduced by EU, that is 2011/65/EC, which is also known as RoHS 2. So original directive is known as RoHS 1, and then generally in terms of it called as RoHS 2, and there is only a small change in that one, that RoHS 2 includes the CE marking, because CE is the safety requirement for all Europe market. So they have introduced that all the electrical and electronic products must be safe for consumers. So they have introduced the CE marking, and additional one requirement they put for the manufacturer or importer or distributor in EU market to keep the record for whatever the compliance they have for their product which they are selling in the EU market, and they should keep the record for at least 10 years, and they need to present all these records to the authorities whenever it is required. Initially, lot of the devices were exempted from in original RoHS, like medical devices, some transportation devices, railway devices, or some army devices were exempted. So in this RoHS 2, they have added the medical devices, monitoring and control instruments also. And in July 22, 2019, there another directive they have introduced, that is 2005/863, which is also known as RoHS 3, but actually it is not RoHS 3 because there is no any legal required change. They have to comply for CE marking, they have to comply for restricted substances, they have to comply, keep the record for 10 years. Everything was same, except they have added some of the phthalates, plasticizers. So all these plasticizers are the part of the insulation material which used in EEE products, because the PVC is very rigid material. So to make it soft, because all the cablings and everything need to fold many times. So these phthalates are added. And in January 2024, they have added, EU has added one more directive called EU 2024/232. And this directive gives the exemptions from the lead and cadmium used from recycled rigid PVC to make the doors and windows of EEE products. This also proposes the restriction of 2 more substances. So once it is applicable, there will be total 12 components which will be restricted, and these 2 are TBBPS, that is tetrabromobisphenol A, TBBPA, and MCCP. So these comes under the category of flame retardants, and they are deliberately added sometimes just to prevent the equipments from the electric hazard or electric spark. Next slide, please. Okay, so these are the list of original and RoHS 3 restricted substances list. In this list, you can see the lead, cadmium, mercury, hexavalent chromium, PBB and PBD. These are restricted. And for all the elements, maximum permissible limit is 0.1% only, except cadmium, which is still stringent requirement, that is 0.01% is only there. Then PBB and PBD, these are polybrominated biphenyls, and PBDE is polybrominated diphenyl ethers. They are restricted, and each of them has the 10 different isomers starting from mono PBB to deca PBD, similarly mono PBDE to deca PBDE. and all for the in total that should be not more than 0.1% in any of the things. In 2019, they have added these 4 phthalates, that is bis 2-ethyl hexyl phthalates, which is also known as DEHP. Bis and di, these two words are same. Bis means also two, and di also means two. So some it is written as DEHP. Benzyl butyl phthalate is BBP, dibutyl phthalate DBP, and diisobutyl butyl phthalate DIBP. Again, they have posed the limit as 0.1% only. And all this testing is required on homogeneous component basis. So how the homogeneous component is made, I'll discuss in the next slide. So next slide, please. Okay. So these are the various products which need to comply with the RoHS directive. That is household appliances, IT, communication, consumer, lighting, all these products must comply. And the compliance of RoHS tells us that product is safe for the environment and for the human beings. And these 4 figures you can see. So if any product requires the RoHS compliance, so all homogeneous components to be tested for compliance of these restricted substances. And how to make the homogeneous component. The RoHS directive says anything which can be disjointed or dismantled mechanically, they all consider as homogeneous material. So first, product must be dismantled into the components, and these components need to further distinguish or distributed into this subcomponent. So like first example is PCB, this printed circuit board. This has the 3 components mainly. One is the green coating. Second is the metal material terminals which are used for making the contacts. And third is epoxy material of bare PCB. So all these 3 needs to test it separately, and the requirement is for individual test. Second photograph is terminal 1, connecting terminal. Again, this has the 5 components which can be divided into 5 components. So by this way, all these homogeneous components need to be tested. Next slide, please. Okay. Now this RoHS EU directive, RoHS, is not limited to EU. It was originated in EU, but since the objective is to protect the human health, their country health, the countrymen health, and the environmental conditions. So many of the countries across the globe have adopted this EU RoHS directive with slight modifications as per their requirement. All these harassed directive across the globe are very much similar to EU RoHS directive, but there may be slight change or slight variation in a small suitable variation in scope or restricted substances list or enforcement mechanism, how they are enforcing. So this is the difference. Next slide, please. Okay, so these are the various regulations across the globe. In a couple of the next few slides, you will see that various regulations across the globe, country-wise. Almost every country has almost similar requirement like EU RoHS with slight modifications. Like if you see the China, there is a level requirement also. And initially this was only for electronic EIP, but now they have added to most of the EE product also, electronic and electrical. Initially it was only for electronics. Then Eurasian economy, in this one the Iceland, which is not the part of EU, but adopted this EU RoHS directive in the similar manner, exactly similar manner. Then India has also adopted the RoHS directive, which is very similar to RoHS 1. They have not introduced till now RoHS 2, that is phthalate. They have not included the phthalate. Then if you see the Japan, instead of Japan, in Japan, instead of saying the RoHS, they say as JMOS. And they have applied, they primarily applied to home appliances and IT equipments. Next slide, please. So Norway. Norway, it is called as POSH, that is prohibition of certain hazardous substances. Instead of RoHS, it is called as POSH. And they have introduced lower lead limit, while in EU RoHS, the requirement is 0.1%. They have introduced 0.01 for lead. They have lowered down. And they have also added few more substances like PCP, that is pentachlorophenol, PFOA, and MCCP. PCP, the requirement is 0.005%, PFOA 0.0001%, and MCCP 0.1%. And it applies to all consumer products, not only EEE product, but other components, consumer products also they have covered in their scope. Singapore, it is called Singapore RoHS, but very similar to EU RoHS, but they have very narrow electronic categories to communication devices and home appliances. They have not taken as wide range of equipments, electronic equipments, as covered in RoHS. Korea is again almost same. Taiwan is also same, except that Taiwan has added that voltage requirement. So any product which is operating in less than 1000 volt in AC current, alternating current, must comply with the RoHS directive. And if it is operating in DC, then the voltage requirement is 1500, 1500. If it is operating less than 1500, it must comply with RoHS requirement. Ukraine is again almost same like EU RoHS, which restrict the 10 restricted substances, similar to EU RoHS. Next slide, please. Then United Arab Emirates, UAE. UAE requires the declaration also and technical files and 10 product certifications for 10 restricted substances, which is almost aligned to the EU directive. Only the requirement is the declaration is required, technical file is required to keep the record and certification. UK, if you see, during the Brexit transition period, they have adopted the EU RoHS directive, and there is slight change from EU, that EU says CE, which is a safety requirement for their countrymen. They here in UK they have added, in place of CE, they have taken UK CE, which is a safety mark for UK market. California is the US first state who has implemented the RoHS, which is known as California RoHS, and this is very similar to EU RoHS. Originally, it was applied to video displays only, but now almost all the categories as implemented in EU, they have covered. Similarly, Vietnam is also in same line of EU directive for RoHS 1, that is 6 substances only. Next slide, please. Okay, so these are the few similarities and differences in RoHS across the globe. The main similarities is that 6 substances are very common in all RoHS directives. They apply to wide range of products, and the main aim is only to protect the environmental conditions and their citizens. While the differences is almost, or they are unique, but there is enforcement mechanism, testing, certification. Some countries have the different limit threshold values, or they have added some extra substances. And the main thing is that implementation timeline and phase wise they are varying, especially they are in that is the case in emerging economies. Sorry. Next slide, please. Okay, so this was the regulatory requirements. Now I will hand over this to Mr. Aftab to take it for technical discussion. Mr. Aftab.
Hi, thank you, Dr. Shobit. Good afternoon, everyone. Myself is Aftab. I'm the manager of Consumer Product Testing Lab in Wimpey Laboratories. So today, me and my colleague Dr. Neha is going to present the testing part of RoHS in electrical and electronic products. Before moving into the RoHS testing, I would like to brief about the Wimpey Laboratory. Wimpey Laboratory have an 18 years of experience in the market, and we are serving 9,000 plus clients across the globe. Wimpey have services, giving services to different areas like food, agri, cosmetics testing, consumer product testing, geotechnical and construction material testing, environmental testing and monitoring, oil and gas testing, and on-site services like calibration. Wimpey is an ISO IEC 17025 accredited laboratories from various organizations like Emirates International Accreditation Center, International Accreditation Services, and Emirates National Accreditation Services. And the lab also secured approvals from various national and international organizations like MOIAT, SASO, GAFTA, and FOSFA. Now, coming back to the RoHS testing. Next slide, please. So coming back to the RoHS testing, the testing parameters are classified into three categories: heavy metals, phthalates, and biphenyls. So the presence of heavy metals like lead, cadmium, mercury, and hexavalent chromium are limited by the RoHS regulation. And these metals like lead, cadmium, mercury, they are analyzed by using the ICP, and the hexavalent chromium, which is analyzed by using the UV visible spectrophotometer. And this presence of these metals can be screened by using the XRF technique also. And in phthalates, 4 parameters are limited by the RoHS regulation, which are bis-2-ethyl hexyl phthalates, that is DEHP, butyl benzyl phthalate, that is BBP, then DBP, which is dibutyl phthalate, and DIBP, which is diisobutyl phthalates. Phthalates are analyzed by using the GCMS technique. Similarly, the biphenyls, 2 categories are limited by the RoHS regulation, which are polybrominated biphenyls and polybrominated diphenyl ether, which are also analyzed by using the GCMS technique. Again, the initial screening for this total bromine can be conducted by using the XRF technique. So now we can see the various product categories which requires the RoHS testing. Next slide, please. So you can see the product list mentioned here. This is the same list which is mentioned by Dr. Shobit, but here you can see some examples against each categories. Like we have a fridge, AC, washing machine, TV, computer, CCTV, camera, etc. So these all products requires the RoHS testing for all the parameters which I mentioned, and the test result should have the test result should be less than the limit which is established by the RoHS regulation. There are products which are also got exemption from the RoHS testing. Next slide, please. So the products like certain military equipment which are using for the national security, and the equipments which are using for the space mission like spacecraft, satellites, etc. And certain medical equipment like a pacemaker, insulin pump, then R&D equipment used for the research and development, non-road mobile machineries which are using in the agricultural sector, railway, waterway, construction machineries, etc. So all these exempted equipments or the materials which are very important for the development of a country. So their production or the manufacturing may require the addition of these heavy metals, phthalates, or the biphenyls in a concentration which is more than the limit established by the RoHS regulation. So maybe because of that, these all equipments are got exemption from the RoHS testing. Now, my colleague Dr. Neha is going to brief you about the standards and specifications which requires for the RoHS testing.
Thank you, Aftab. This is Dr. Neha from Wimpey Laboratories. I am working here as an R&D chemist. My colleague Aftab has talked about the product category range as well as the exempted product under the RoHS regulation. Now, I will be continuing the presentation by talking about the standard which we are using in our laboratory as well as the testing method. The hazardous substance list we are testing with the standard IEC 6232-1/5. Cadmium. For cadmium, we are using the standard IEC 6232-1/5 again. For mercury, we are using the standard IEC 6232-1/4. For hexavalent chromium, we are using IEC 6232-1/7, which is divided into two parts, part 1 and part 2. Part 1 comprises the detection of hexavalent chromium in metal parts, and part 2 comprises the detection of hexavalent chromium in polymers and electronic part. For the detection of biphenyls, we are using the standard IEC 6232-1/6. For phthalates, we are using IEC 6232-1/8. The specification limit of all the substance other than cadmium is 1000 ppm. For cadmium, it is less than 100 ppm. Now, I will be describing how we are testing our product in our laboratory. So, first, when the customer is bringing some product for testing in our laboratory, first of all, we are dismantling the product and we are taking out the high risk element from it. And this high risk element is the list is given to us by the customer itself. So we are taking out 3 to 4 parts from the product and we are crushing it, and initial screening we are doing with the XRF as per IEC 6232-1/3 part 1. And suppose we found after initial screening, suppose we found that the presence of heavy metal is under the specification limit, then we will not move to the further analysis. We will stop the test right there. And it can be a cost reduction also. After the initial screening of XRF, suppose we found that some of the metals are under the higher limit, then we are moving to the further testing. Like for lead and cadmium, we are analyzing this lead and cadmium under 3 categories. That is, we are detecting it in polymers, in the metals, or in the electronics. For polymers, we are using dry ashing method as well as we are also using microwave digestion. For metals, we are using microwave digestion method. For electronics, we are digesting it with open digestion with aqua regia, or for this also we are using microwave digestion. Then we are moving it to the ICP analysis. For mercury, again we are using microwave digestion and then we are continuing the test with ICP analysis. For chromium, we are testing this chromium in 2 parts. Chromium present in the metals as well as chromium present in the polymers or the electronics. For chromium present in the metals, we are extracting it with the help of the boiling extraction method, and then we are running the sample into a UV visible spectrophotometer. For chromium, which is present in the polymer and electronics, we are extracting our sample with toluene and magnesium chloride, and then again we are running our sample in UV visible spectrophotometer. For phthalate, we are analyzing the phthalate into 2 categories, in soluble polymers and into non-soluble polymers. For non-soluble polymers, we are extracting our sample with Soxhlet extraction method following by N-hexane, and then we are analyzing it with the help of the GCMS. For soluble polymers, we are extracting our sample with sonication and ACN method, and then we are again running our sample into the GCMS. For biphenyl, again, we can categorize into two parts, soluble polymers and non-soluble polymers. For non-soluble polymers, we are again doing soft select extraction method followed by toluene, and then we are running our sample into GCMS. For soluble polymers, we are doing sonication followed by toluene and isooctane, and then we are running our sample again into the GCMS. Here, I want to mention that if any of the hazardous substance doesn't come in the specification limit of RoHS, we can say the whole product as a whole doesn't comply with RoHS. Suppose in one element in one product we found only the lead is more than the 1000 ppm, then we can say this product doesn't comply with RoHS. Next slide, please. Here come to the some product which we use in our day-to-day analysis. These type of product come to the Wimpey Laboratory for testing. So here is the hair styler which we have tested here in our Wimpey Laboratory, and as per our client demand, out of the whole product we have tested 4 parts of it, like mesh, electric heater, fan and electric fire, and we have tested all the 10 parameters for it, like 4 phthalate, 2 biphenyls and 4 heavy metals, and we found that this product comes under the this product comply with the RoHS regulation. Next slide, please. All the testing standards which come under the scope of RoHS are accredited by IAS in Wimpey Laboratory. Thank you so much. Now I would be inviting Mr. Noor to continue from here.
Thank you, Dr. Neha. My name is Noor Mirza. I'm the VOC business head at Cotecna. I'm going to explain about the certification procedures that we have in GCC countries for RoHS compliance. So before we get into it, a short introduction about verification of conformity, otherwise known as VOC. So VOC ensures that the quality and safety regulations are met, making sure that the government imposed regulations are complied for the products that are imported to the destination countries. And Cotecna is listed with a number of entities across the world to certify products under VOC program. And in the Middle East, we are listed with the Saudi Arabia authorities as well as in UAE authorities to certify products under RoHS compliance. Next slide, please. So take you through the certification process in the GCC countries. Currently, there are 2 active countries who have implemented the RoHS compliance, one being United Arab Emirates and the other is Saudi Arabia. United Arab Emirates has implemented this with the help of a ministry known as Ministry of Industries and Advanced Technology. However, Saudi Arabia has a separate certification body known as SASO, or certification entity known as SASO, which has also implemented this for a limited number of products. Next slide, please. So to take you through the timeline on implementation of this in the GCC countries, UAE first implemented this back in 2017 when they published a resolution on April of 27, 2017. And over the next few years, a lot of products were brought into the fold of certification for over, I think, 3 different phases were implemented. And the equivalency of EU regulation RoHS 3 is similar to that of how UAE implements RoHS compliance. In Saudi Arabia, the regulation was published back in 9th of July 2021, and the actual implementation started from 4th of July 2022. The compliance in Saudi Arabia is similar to that of EU RoHS 2, and the limitations, again, with respect to this restricted substance are again different from each of these countries. So I'll take you through them in the next slide. So as explained in SASO or in Saudi Arabia, the limitations for restricted substance control are limited to 6 restricted substances, which is cadmium, mercury, lead, hexavalent chromium, PBB, and PBD, with the limits being similar to that of how EU RoHS 2 implies. And similar application is also available for Moyat, where additional phthalates are being also controlled with the same threshold as that implemented in EU RoHS 3. So when I say equivalency, the equivalency is limited to the restricted substance control. However, the implementation of certification is much different in UAE and Saudi Arabia. Next slide, please. So the regulated products, as my colleagues have repeatedly explained, are limited to 11 categories. However, in UAE, the 11th category covers all products that are not part of the first 10. So it's self-explanatory that all electronic products that are electrically charged has to be controlled by this particular regulation in UAE. So it starts from the large household appliances to small to IT telecommunication equipment, consumer equipment, lighting, electronic tools, toys, medical devices, monitoring and control instruments, automatic dispensers, and all other products that are not part of the first 10 categories are covered by 11th. Of course, there are exemptions provided to some of the products where it is not possible to exempt out these restricted substances like medical usages and also some military applications. These are very explicitly mentioned in the technical regulation issued by MOIAT. Next slide, please. The control with SASO, however, is much different. The categories are limited to what you can see on the screen, where small household appliances, large household appliances, telecommunication devices, lighting, electronic equipment and tools, toys, and tools for monitoring and control are all implemented. Medical device, however, is not part of the RoHS compliance implementation in Saudi Arabia yet. Next slide, please. So to take you through the certification process, the conformity assessment procedure is broadly the same between both UAE and Saudi Arabia, where the scenario one dictates that if the applicant has a full product test report of the product being applied for certification, irrespective of as many models as there in the application, then a full product test report would be sufficient along with the declaration of compliance. Of course, the test report must be available from a third-party laboratory testing all subcomponents and sub-assemblies that are part of this particular product. Next slide, please. In scenario 2, however, this is where the EU similarities come into effect. As you can see here, the requirement is starting with the risk assessment file, or otherwise known as technical documentation, as termed in the MOIAT implementation guideline. This is very broadly described in the IEC 63000 standard, or otherwise, which is similar to EN 50581, where the requirements of technical documentation is explicit to each of the component used in manufacturing of the device. The provided test report for critical components is identified usually by notified body, who goes through these risk assessment and technical file and identifies the highest risk products, and then notifies the laboratory and to the customer to test the components. Here it is more than enough that the manufacturer provides test report for 3 high-risk components and not of the full product. So 3 components along with the risk assessment file and also a declaration of compliance only for the components that are being considered here needs to be provided in this scenario. Next slide, please. To give you a small brief about what has been implied here in the EN 50581 standard is that the manufacturer takes the responsibility to make sure that the component as well as the supplier both are complying with the requirements of the regulation. Here, the risk assessment is broadly drawn based on this standard, and the risk is considered both in terms of supplier as well as the material. So depending on the material, if it is high-risk material and also the supplier, which is qualifying as a high-risk supplier, then the manufacturer has the right to request for an analytical test from the supplier of the component. And again, if it is classified as a low-risk supplier or a low-risk material, in this case, a contractual obligation supply declaration or material declaration would be sufficient as requested by the manufacturer or brand owner. However, the matrix of risk definitely defines high-risk products with high-risk suppliers, and these are considered as critical components according to how UAE perceives a high-risk product or critical components. Next slide, please. So to broadly inform about the material risk, the manufacturer has the right to understand what kind of material has most amount of risk. So that is identified with the help of the material declaration provided by the suppliers. For example, stainless steel is a very low risk material. compared to that of a black plastic, for that matter, or if there is anything else that might be very considerate. But if you look at a power supply where it's a subassembly of about 150 different components, in this case the subassembly itself is considered as a high risk components on its own, because it has a lot of different components coming together to make into an assembly. So here the description of material risk is very detailed and has to be done by the manufacturer by understanding the different materials that are part of each of the supplied components. Next slide, please. On the other hand, the supplier has a lot of questions to be answered before being qualified as a reliable supplier, where the supplier may be located in what part of the world, if the acceptance can be just a declaration or a material declaration, and compliance history of the supplier. So there's a lot of understanding on how the supplier can be qualified as a low risk supplier. That's something that is described by the manufacturer in their technical documentation and their procedures on how to qualify a supplier based on the risk assessment performed. Next slide, please. So to give you a small understanding of risk identification, both two main risks has to be taken into account, the material and the supply risk. So material risk is applicable for everything that is part of the bill of material, including the solder paste or anything for that matter that is being used in the manufacturing or being part of the component. It should all be covered in the material risk, where the supply risk depends on the mass production variation and batch compliance to specification. This depends on how risk profiling has been performed by manufacturer for different component suppliers. Some of the high-risk materials, to sum it up, would be restricted substance being intentionally added for achieving an expected function, known high level of impurities, recycled material, significant compliance failure statistics, as well as traceability being unable to be established. So these are some of the high-risk material that a manufacturer can consider as high risk in the way that they perceive this risk identification. To sum it up, there are two methods of registration for certification. One method where a full product is being tested in a 17 or 25 accredited laboratory, and along with that, a declaration of compliance. And the second method of registration would be to provide a risk assessment document detailing about the supplier as well as the material risk, where high-risk components are perceived based on the risk assessment performed by manufacturer and considered as a critical component. And any three high-risk components can be tested along with the declaration of compliance to complete this registration process. I think that's about it. Going back to Awani, thank you so much for the time.
Thank you, Mr. Mizra, for the detailed explanations on the certifications and the conformity assessment procedure. Now we shall move on to the Q&A. We have received few questions through the registration process. First question is for Dr. Neha Goyal from Wimpey Laboratories. Are all these standards for testing discussed during the presentation applicable for testing?
Yes, I have discussed all the standards while telling about the testing procedure, we are doing in our laboratory.
Okay. Also, there is one question that we have received on the chat box through Mr. Rakesh Mohan. Is RoHS a destructive test?
This RoHS is destructive test. I'm Dr. Shobit from CPS Gurgaon. This RoHS is destructive test, but if you are going for XRF screening, the component may not be destructive if it is concluded in one go. If final conclusion is required, wet analysis, it is a destructive test.
Okay. Can we have the another question, please, Dana? How long is RoHS certificate valid for?
Okay, so this RoHS certificate is generally valid for 5 years, unless and until there is no change in the production or supplier or whatever the material, raw material they are using in the production. There is no change. If there is any change, this certification need to revalidate immediately.
Right. Okay. So third question is for Mr. Virza from VUC team. Is the certificate accepted instead of test report for certification in the Middle East?
So in the GCC countries, that is UAE and Saudi Arabia, CE certificate is not considered as a valid document for registration. The process has to go through the testing before certification. So C certificate is not acceptable. However, test report, if there is existence of test report along with the C certificate, it might be considered. However, C certificate alone is not accepted.
All right. So coming back to Dr. Shobhit for the next question. Is RoHS testing mandatory?
Yes, where the RoHS regulations is there, it is mandatory, and primarily it is mandatory for importers, manufacturers, or distributors in selling countries. But later on, they can ask their supplier and sub-supplier to comply with that. And in that case, all the suppliers for any manufacturer, they will send their components, whatever they are supplying, they will send to testing. And testing, if it is complying to the requirement, the product will go for manufacturing the final product.
All right. Okay. Next question, please. Since testing is on homogeneous component level, how testing cost can be reduced? Mr. Aftab from Wimpey Laboratories, could you please answer this?
Yeah, okay. So initially we can do the screening with the SRF machine. And if the test results are falling in the region of pass level, then we can conclude that with the result of XRF. So no need for going for the wet analysis. But if the test result is falling in between the non-conclusive area, then we have to move with the wet analysis. I can give an example like if, for example, the specification limit is 1000 ppm. So by doing the XRF screening, the technique uncertainty has to be considered like 30%. So we can have a pass level less than 700 ppm. And if the test result is falling below the 700 ppm, then we can conclude the testing with the result of XRF. But if the test result is going above 700, like a range like in between 700 to 1300, then we have to go for the wet analysis. Then only we can conclude the test result.
Right. Thank you, Mr. Aftab, for the detailed explanation. So now this was a yes, Dr. Shobhit.
One more thing I would like to add in this one, that what the Aftab said in continuation to that, if the results where the limit is 1000 ppm, if result is between 700 to 1300 ppm, then need to go for wet analysis to draw the final conclusion. And if it is more than 1300 ppm, then simply it can be said that it is non-compliant. This is for lead, cadmium, mercury. Sorry, cadmium is 100 ppm. So here for cadmium the requirement is from 70 to 130 ppm only, not the 700. Instead of 700, it is 70 ppm and 130 ppm. And for PBB and PBD, since these are the brominated compounds, here the requirement is only up to 300 ppm. So the requirement for PBB and PBD is 1000 ppm. But in XRF analysis, if bromine goes above 300 ppm, then it requires wet analysis for final conclusion.
Okay, all right. Thank you, Dr. Shobhit. So it was a wonderful session, and this is for the audience. If you would like to have any information on any of the sections that we have covered today, or if you have any requirements pertaining to testings or the certifications, you can reach out to us at the given address and the mail IDs. And we'll be sending you a thank you mail along with the recording of the webinar and the subscription link for the upcoming events and the newsletters. Thank you all for joining the webinar. It was wonderful to interact with you all.